Now let us discuss the problem based on verification of mean value theorem. Verify mean value theorem for the function given below. F of x is equal to x squared in the interval, in the closed interval 2 and 4. Let us proceed. We need to verify this. What is the given function here? The given function is f of x is equal to x squared. F dash x, the differentiation of x, which is nothing but dy by dx. So that gives 2x. Okay, right. Now let us proceed. What is f of 2? Let us substitute here. So 2 squared, that is equal to 4. And what is f of 4? Because the interval it is given. So f of 4 is equal to 16. That is also over because 4 squared, that is equal to 16. Now we already know, according to the mean value theorem, the given function is a continuous, means it is differentiable also. It is continuous in the closed interval and differentiable in the open interval 2, 4. Now, according to mean value theorem, f dash c is given by f of b minus f of a whole divided by b minus c. We were discussing about that the secant is a parallel to the what? The tangent of the slope at c. So now f of b can be substituted here 16 minus f of a 4 divided by 4 minus 2. So it gives 6. So it means f dash c is equal to 6 according to this equation. So we can substitute this. So f dash x is equal to 2x. So let us replace at c. So f dash c is equal to, here it is 2c. Therefore 2c is equal to 6. C is equal to 3. Therefore 3 here it belongs to, it is an element of, it is a, element of 2, 4 interval, open interval. Okay. Therefore f dash c is equal to 6. It means that is we have to multiply by 3. So the mean value theorem is proved or verified. Understand?